Hello. Today we're going to talk about Topic 3, Section 9, Planar Transformations. So there are four types of transformations, all right? And these are the four. You start with the reflection. That's when you flip something across a line, okay? So if we have this object, okay, then its flipped image is like looking in a mirror, all right? So C is now going to be on the left, A is on the right, and B will still be up top. Okay. Now for rotation, that's when we rotate off of a vertice, all right, or off of a point by a certain angle. Okay, so this would be, oh, I'm sorry, these are the new image, so they usually have a prime, so just like a little apostrophe off to the right. So for here, if I have, let's say this is A, B, C, then, oh, I'm sorry, that's not the new image. This is the original, and then it rotates over here. Okay, so here the translation, that's when you just move it, okay, you slide it around, okay, and enlargement is kind of like where you zoom in and out, where you're staying put, but you're kind of like bringing the object closer or further away from you. Think of it like that. All right, so let's do some transformations. So the triangle is transformed with this matrix, so find the coordinates of the vertices. All right, and so how we can do a transformation that it is in your IB booklet. Okay, so it's done by this. So we could do 1 point at a time. So this is our transformation matrix and multiply it by the point. So we have the matrix 3, 1, 0, 2, and we multiply it by the matrix 1, 1. Okay, so we multiply that, we should get 4 and 2. So the new point, so this is now the new image for B. So that's at 4, 2. Okay, and you keep doing it for the other ones. Now, instead of doing it one at a time, you could do both both points at the same time. So what we do is we've got 3, 1, 0, 2, and we can multiply C and D. So put point C here and point D here. This was originally point B. Okay, so if we multiply that out, let's see, we should get 10, what is that, 6 and 8, so what is that, 2, 4. So now C prime is 10, 2, and D prime is 2, 4. Okay, so those are the new points. Okay, so this one actually did a lot more. I can't really put that on my graph. Hold on. Okay, so now, sorry, I had to graph that. So now you can see that this is what I called B prime, and let's see, 10, 2 is C prime and D prime. Okay, so that way you guys can see the enlargement here. Okay, so there were some transformations. Well, not quite an enlargement. Well, we'll talk about what that is. But this is how you can do any kind of transformation. You basically multiply it by a matrix. Okay, so let's see, find the coordinates of the new transformations. We can do this with our calculator, so that's going to be fun. All right, let's see, go to your matrix. So second matrix, we're going to edit our matrix. We're going to make our transformation matrix. So that's a 2 by 2. We've got 2, 1, 2, 2. Then I'm going to go back. All right, so second matrix, going to go back there, and I'm going to edit B, and that's going to be my points. So I need 4 points. Nope. See how we did that? You can always catch it there. So it's a 2 by 4, right? Rows by columns. So 4 columns is what we need. So the first one, we have -1 and 1. Then, let's see, -2, -1, using the arrows, so it's easier. And then, let's see, 2, 2. Oh, I guess I have to enter. I don't know, it's finicky. All right, so then, and then 5, -5. There we go. So now we can quit, and now we can go back to our matrix, hit matrix A, then multiply, go back to matrix, hit matrix B. Bam. There is our answer. Okay. Great. So the coordinates of the new vertices, so A prime is -1, 0, B prime is -5, 6. Oh, I guess I should write this out. So what I did is we did 2, 1, 2, 2, and I multiplied by -1, 1. Sorry, I always got to show my work. And then we get -1, 0, -5, 6, 5, -6, 8, 0. So we have A prime is -1, 0, B prime is -5, -6. Then we have C prime is 6, 8, and then D prime is 5, 0. Perfect. All right, so now how do we go the other direction, right? That's an example 4. So we're going to go in the opposite direction. So we know that we've got a transformation matrix. So let's see, A, B, C, D. And we're going to multiply it by our points, -2, -2, 1, -1. And we're going to get our new points, 4, 4, 2, 2. All right, so how do we get our transformation matrix? All right, so that's just a matter of moving that to the other side. So to find out what A, B, C, and D are, all we need to do is take that right matrix, multiply it by this one that we moved over, but it's not just it, it's its inverse. So make sure you multiply by the inverse. You can do this on your calculator. So if we go to our matrices, we edit them. Gonna make a 2 by 2. Let's do the A matrix. Okay, then I'm gonna do my B matrix, is the one I want to do the inverse. And -2, 1, -2, -1. Okay, so now when I do the matrices, I'm going to do matrix A times matrix B, right there, and then I'm going to do the little inverse. Isn't that great? Wonderful. All right, so then we get our transformation matrix, which is 0, -2, 0, -2. So there is our answer. So we've got our answers, the points there, and the matrix there. All right, so now let's do some reflections. All right, so if we think about this, we're using the reflection line y equals x. So you should recognize that that is a 45-degree angle. So we're going to reflect it across a 45-degree angle through the origin. And since we're just flipping y and x, we'll think about this. If this is 1, 3, then the reverse image is just, or the reflected image is where we literally flip x and y. Now, of course, that's how we know. We should know that. Now, if we wanted to prove it, we could just say that this is the point A comma B. And then we know that if we were to draw a line right here, right, that would be a perpendicular line and that this would be the midpoint. Okay, so this would be the same length as this. Okay, so then that point would be, I don't like how I drew that. Yeah, sorry. Okay, so that point would be 1 plus a over 2, 3 plus b over 2, and then that is on the line y equals x. So 1 plus a over 2 equals 3 plus b over 2. Okay. We can rearrange that. We get a equals b plus 2. All right. We also know that the slope, hold on. So we know that the slope of this line, y equals x, is just 1. So the slope of this one must be, so the slope of a prime should equal -1. So then we know 3 minus b over 1 minus a is equal to -1. We can rearrange that. We get a equals 4 minus b. We can solve those. We get a equals 3 and b equals 1. So we can prove that our point, I don't know why I wrote it like that, is 3 comma 1. Okay, so we can solve it that way, right? Hopefully, visually, right, when you flip across that 45. Okay. All right, so there are formulas for your reflections. So they are in your formula booklet. So if we are reflecting across this line, y equals tangent theta of times x, all right, it's across that line, okay? Or you're reflecting it with that angle. So, all right, first of all, let's do this example. If the transformation matrix for reflections is this, okay, so that means that cosine 2 theta must equal -1/2, okay, because that's cosine of the first one. Then I should know that sine of 2 theta is equal to the square root of 3 over 2. Okay, and so on. Now, I can do this using your calculator, right, to double check things. So we do second cosine, right? Or I'm sorry, yeah, the inverse cosine of -1/2. Hold on, am I in the right mode? Nope, I'm in radians. Want to always be in degrees. Okay, so let's try that again. There we go, should be 120. So that means that 2 theta equals 120. So this tells me that theta equals 60. Okay, let's verify the rest of it. So second sine, let's do square root of 3 over 2. That's 60. Okay, so the inverse sine. So that means that 2 theta equals 60. So theta equals 30. Okay, so now you're probably thinking, what's going on, Miss Cross? The angles don't match. Okay, that's because, let's see, these angles are small, so they're in the first quadrant. If we are doubling them, then that means we are in the second quadrant, and so sine is going to be positive in both. Okay, so the smallest one that they would take is, yeah, so either way that didn't work, or either way, so let me show you. So cosine 2 theta, so let's check the 60. So that would be cosine of 120. Okay, that gets us our -0.5. But if I do cosine and plug in the 30, that's cosine of 60, That's positive 0.5. It can't be this one, okay? We just tested it, okay? It doesn't work for the other ones, okay? But we also know, all right, hopefully you remember the unit circle. So sine of 2 theta, if we do sine of 120, all right, that's the same as if I had done sine of 60. Okay, because the first and second quadrant sine is the same. So that's how we can check it, okay, using our calculator. So theta is 60 in this case. And we can test it with the other two as well, okay? Well, I guess that's just negative. All right, but yeah, you can see that those are the same. Okay. So let's see. The vertices are represented by this. The triangle is reflected in the line y equals negative x. So find the new one. All right, so what are we going to do here? First, we need to figure out the angle. So maybe you need to visualize that line. Well, I guess you don't need to do that. That to me seemed like it would be so much easier, because then you know it's this way. So then you know that this is 45 degrees, and so this is 135. Okay, so here we would do 135 degrees, but remember this is also tangent theta is supposed to be that number out front. So if I want tangent to be negative, okay, then I'm going to go to my second quadrant, and I want -1, so I'm at that 45. Square root of 2 over 2, square root of 2 over 2. So that's how another way we can get tangent is 135 degrees. So now we can get our matrix. So our matrix would be cosine of 270, sine of 270, sine of 270, negative cosine of 270. Ooh, that's not a 0. All right, and if we work that out, then that's just 0, -1, -1, 0. So now we just take that. I'll just keep changing colors, because why not? I'm in a festive mood. All right, -1, 0. Then we multiply it by our points. And we get our new ones. That's great. And again, we can plug this into our calculator, or we can just multiply it out ourselves. Either way, you'll still get the same answer. And it said find the vertices, so those are going to be in point form. So -1, 2, -1, -1, and 2, -3. Okay? So these are your answers. Ooh, that's a terrible circle. Okay. All right, so if you get a problem like example 1, all right, here we're going to stretch it horizontally. So first, it doesn't really say that we're doing that. It just says to multiply it by that matrix. So you take each one of these points, 1, 1, 1, 3, right, and multiply it by all those. If you do that, you'll get this as A prime, this as D prime. Let's see, C is going to be, ooh, almost off my points, or off my graph here, okay, and that's B. So our new quote-unquote square is going to be right here. So I horizontally stretched it, okay? So that is when I left my y's alone, but I increased my x's. So notice that's what's happening. That's in our formula booklet. All right, when we do our multiplying, this is changing your x value. Okay, when you multiply, it's changing all the x's. So that's why it's only stretching the x's. Okay, and then here, so consider this after a horizontal stretch with a scale factor of 3. So we can take our matrix 3, 0, 0, 1. K is our scale factor, and multiply it by our points. let's see. This should give us, hold on. Oh, sorry, I thought I wasn't looking at the right thing. Okay. -3, 6, 2, 4. Okay, so that is our new points. So A prime is -3, 2, and B prime is 2, 4. But we're not done, all right, because it's asking for the length of the image of AB. So find the distance of AB. So that's using our distance formula. -3 minus 2 squared plus 2 minus 4 squared. We end up with the square root of 85. Okay. All right, so now we're going to do the vertical stretches. So you can imagine that the first one that we're doing, it's not affecting the x's, but it's affecting the y. All right, so when we adjust all these points and multiply it by this new matrix, what's going to happen is B prime is going to get further out. So D prime, let's see, that's, ooh, it's like way down here. And A prime just moved a little bit, and C prime moved a little bit. I don't think I did this one enough. 4, 5, yeah, probably. So our new quote-unquote circle has certainly become more elliptical. Okay, so I know I didn't draw that the best. You can look on Cognity for the better one, but this is what's happening here. Okay, so when you're multiplying it by this matrix, okay, that's what's happening. And again, we can just, if we weren't sure what was going to happen, right, because it certainly didn't say what was happening here, we could write down all the points and multiply them by the matrix, 1, 0, 0, 2. And let's see, A is 4, -1. B is 2, 1. C is 0, -1. D is 2, -6. No, what am I doing? 2, -3. Okay, and then that will also give us our new points. All right. All right, example 4. So consider this line segment. Find the endpoints stretched by a scale factor of 3. All right, parallel to the y-axis. So imagine that. If this is our x and y-axis, we're parallel to the y-axis. So we're stretching it vertically, right? We're pulling things up and down. So that's a vertical move. Okay, so a vertical stretch. All right, and then find the length. So this is just like the last one. So we're going to multiply it by 1, 0, 0, 3, our new points. Our old points. And let's see, to save time, I'm going to have it all written out. So let's see. It looks like they didn't even finish it on Cognity. Oh, sorry. -1, 6, 2, 12. Okay, so yeah, it didn't finish it. So let's see. The new points are -1, 6, and 2, 12. So our new distance is, I don't know why I made it that long. Okay, so -1 minus 2 squared plus 6 minus 12 squared. What is that? -3, so 9 plus 36, so square root of 45. All right. And there we go. All right, so now we're going to do enlargements. Oh, and guess what? That formula is also in your booklet, so make sure you know where to find it all and that it all makes sense because you can look at it. Okay, you're going to have that on the test. So think about it when you see these kinds of questions. So we are going to enlarge it by this matrix. So we can take each coordinate. So A is 1, 1, B is 3, 2, and C is 2, 1. All right, we can multiply, and let's see, what are our new points? Well, I have it right here actually. Okay, so let's see, A prime ends up being 2, 2, B is 6, 4, and C, I know I could have multiplied, but I'm just tired. All right, so these are our new points. Okay, notice what happened. Okay, everything just doubled. Okay, when you multiplied it by this, like left diagonal, right? The right diagonal is zeros. I'm literally, it looks like multiplying everything by 2. Okay. So that's an enlargement. That's zooming in and out. So if we multiply it by a number bigger than 1, we're making it bigger, so we're enlarging it. If we multiply by a number less than 1, okay, between 0 and 1, I mean, then the number's going to, the figure's going to be smaller. Okay? So, let's see, we're going to enlarge it by a scale factor of 3. So it's just multiplying matrices. I mean, that's really all we're doing here. The key is not to overthink things. Okay? So this is -3, 9, 3, and -6. Okay, so the new coordinates are going to be -3, 3, and 9, -6. All right. Okay, rotations. Rotations, again, have a formula, so know what kind of matrix you're looking at. You have an angle, and it's going around the origin. Now make sure you pay attention to anti-clockwise or counterclockwise or clockwise. Okay, so make sure you're paying attention to that. So example 1, write down the matrix. So just start by finding the matrix with a rotation of pi over 3 about the origin. So anti-clockwise, so that's going to be this one. So that is cosine pi over 3, sine pi over 3, negative sine pi over 3. I said this in the wrong order, so excuse me. All right, so then this one is going to be, what is cosine of pi over 3? That is 1/2. Sine of pi over 3 is -√3/2. Well, because it's negative there. Then it's √3/2, and then 1/2. So this is your transformation matrix. Okay, hopefully that makes sense. Here you can practice it with number 2. So you're doing a clockwise with pi over 3. So cosine pi over 3, negative sine pi over 3, so this is again how I'm just showing my work. You know the drill. Okay, so cosine pi over 3, we just did all this. 1/2, then this is going to be -√3/2, and positive √3/2, and 1/2. There you have it. All right, so now let's do example 3. So now we want to write down the new coordinates, and after rotating it 150 degrees anti-clockwise. Okay, so our transformation matrix, all right, is going to be cosine 150 degrees, then negative, I don't know why I put sine theta, 150, and then cosine 150. We get that matrix, and we multiply it by our new coordinate. Okay, so then this, we can use our graphing calculator to actually do this for us. Okay, because yeah, 150 isn't anything nice. Okay, so you know how to do this with your calculator. I would plug them in, multiply it. This is going to come out, let's do the third decimal place, 4.964. That's what Cognigy did, 598. Okay, so the coordinate is, or the new coordinate is this. And that is a 5, not a 3. Okay, there you have it. All right, translations are probably the easiest because you're just sliding your image around. Since we are sliding, we're not manipulating the distance and area or anything like that. So we are doing it through addition. So you have to remember this. This is not on your, it's not given on your IB booklet, so remember it. So if we were changing the point, -2, 3, and we're changing it through a translation, we're going to add. So if it's a translation, you're going to add. So -2, 2. So my new one is going to be -4, 5. So you'd write it as a point. Okay, because it asks for the coordinates. All right, now for example 2. All right, so if it's translated first by this vector and then by this vector, we could do each point by itself. So like for instance, if I started with A, I could do -6, -2, and then add 2, 3, and then add 1, 1, and keep doing that for B and C, right? Or I could simply combine those and simply add 3, 4 to all the points. Okay, so A prime would be, oh, I'm sorry, I'm not doing this very good notation. So this matrix, we're adding 3, so -3, add 4, 2. So then A prime would be -3, 2. So instead of just adding this one and then adding another translation, we could just combine those translations and simply add one matrix. Okay? So with adding, you're allowed to mix things around. Okay, so composite transformations, that's when we're doing more than one thing. Okay? So multiple transformations. So we start with our point A, and we have a horizontal stretch parallel to the x-axis, right? So a horizontal stretch, scale factor of 2. So to deal with that, we use the matrix. Look at your formulas. 2, 0, 0, 1. And we multiply it by the matrix 3, -2. And we get 6, -2. All right, then point B is transformed to C by a rotation matrix by 60 degrees anti-clockwise. Okay, so for the rotation, we need to multiply it by cosine 60, negative sine 60, then sine 60, and cosine 60. And we're multiplying it by that last matrix, that new B. Okay, so we multiply this out, we get, let's see, I want to do exact though. Well, I guess I don't need to right now because I'm asking for the single transformation matrix. So either way, we know the final answer, or the final point that's going to happen here would be 4.73, 4.20. Okay, So that's our new point. So that's point C, or represents point C as a matrix. Now, we want to realize what we did here, okay? Because we want to write down a single transformation matrix that meant what did I do for everything? Instead of doing it twice, give me one thing, okay? So the first thing I did was I started with my point, and then I multiplied by my horizontal stretch. And then I multiplied by my rotation. So cosine 60, sine 60. Okay, so then here, if I just want a single matrix representation, I could multiply these first. So when you multiply those together, you end up with 1, negative 0.866. Ooh, that's not a negative, that's 1.732 and 0.5 times 3 negative 2. Okay, and that should give me my new point. So if I wanted to double check it, I could see if this matrix times that gives me that. Okay, so that was, yeah, correct to 4 sig figs, even though it said a 3 here. I don't know why they did 4 in Cognitive. Either way. All right, hopefully this makes sense. Okay, so our answer, sorry, I didn't actually say that. So write down the single transformation matrix would be 1, 6, 6, 1.73, and 0.5. 3 sig figs. All right. Example 2. So let's do this. All right, so why don't you take a minute? I'd pause it and try it on your own. Okay. Now, let's see. We want to write down the reflection matrix and the rotation matrix. So let's do F is the reflection matrix. So we're doing that with it being 60 degrees, or pi over 3, and around the origin. So that's cosine 60, sine 60, negative sine 60, cosine 60. Oh, nope, negative and positive. Sorry, had the wrong negative. Okay, so that's the reflection matrix. And sorry, I guess I should have reiterated that this tangent of what is square root of 3, so that's how I got my tangent is 60. Okay, so I was doing, actually, so this should all be, what I get for not paying attention to what I was doing. I was trying to jump it and go too fast. This angle is 60. What goes in here is 2 theta. Ugh. I hope you guys had that right. Woo. Okay, that's what I get for Russian. Okay, so then this, that's your rotation, reflection matrix. So we could round that if we wanted. 6.866.5. Yeah. Then your T, your rotation matrix. Okay, so since it is okay, this one is cosine pi over 3. Then we have sine pi over 3. I believe the negative is right here. And cosine pi over 3. Now, Cognity flipped it into the counterclockwise rotation. You can leave it and do the clockwise because that is on the IB booklet. Okay, make sure you can locate that though. Find it. It's on the big packet one, I know for sure. Okay, write down a single matrix that represents F followed by T. All right, make sure you pay attention to the order of how you're doing things, meaning that first we take our points and we reflect it and we do the reflection. So we do F times our original points. Okay, so by our points. So matrix F times the points, that kind of blended together. Okay, then we multiplied by T. Okay, so that's how we need to make sure we do this. We do T times F. Okay, so you're doing T times F. All right, you multiply these, you should get the matrix 0.5, 0.866, 0.866, negative 0.5. All right, so find the matrix representing the image of the segment under the two transformations. So that's where you literally take that matrix, 0.866, negative 0.5, that's 0.5, and you multiply it by your points. So 2, 1, 1, 3, you get new points. So 1.866, 1.232, 3.098, negative 0.634. All right, then, and then there are your, well, that's the final answer. Yeah, it's asking for the matrix, not in coordinates. So you leave it like that. All right, so affine transformations, I'm not really sure how to pronounce that, but these transformations, the image is enlarged and kind of rotated, and it's, or it may be in a different position, not necessarily always, or translated. And when you do that enlargement and you move things around, that's when you start getting your fractals, and that starts getting to the really cool stuff. And that's why we're doing, these transformations, is because that's when you get into the cool part of math. Okay? All right, so let's do example 3. I'd pause it, try it on your own. I don't know why I just said try it on your own. I haven't explained this one. It's so similar to composite transformations that anyway. So we're doing an enlargement with a scale factor of 2, followed by an anti-clockwise rotation of 180 degrees. All right, finally it's translated by the vector. Okay? Okay, so we said an enlargement with a scale factor of 2. So an enlargement with a scale factor of 2, so that's just 2, 0, 0, 2. So that's our enlargement. Then we have the anti-clockwise rotation of 180 degrees. So that's just cosine 180, sine 180, negative sine 180, cosine 180. So that's just negative 1, 0, 0, negative 1. Okay. So we have both of those. Well, it's first done by that and then the green one. So to get this matrix, all right, what we would do is we would do negative 1, 0, 0, negative 1 times our enlargement. Okay, so then this one would become negative 2, 0, 0, negative 2. Just making sure. Okay, so therefore A, B, C, and D would line up there. And then E and F, we are just adding. Okay, well, when we add, that's a translation. Okay, translation is when we add. So the new matrix, or A, B, C, D would be this one, and then E and F would be that one. Okay? So find the image, 3, -3 under that. So to do that, let's just use this color. I don't care. Okay, so we're going to do -2, 0, 0, -2 times our new point, add the translation, and then we're going to get a new image. We work all that out, we get that. So the new point is -5, 7. Okay, hopefully that makes sense. All right, let's see, last one is the area of a new transformation. So it's literally take the determinant times the area of the object. Okay, so an object with this area is transformed by this matrix. So the area of the new image is just the determinant of this transformation times 3. So the determinant here would just be 2 minus -2 times 3. So that would be 4 times 3. So our new area is 12. All right, so hopefully that was simple enough. Okay. All right, let's do number 2. So we've got a triangle with these vertices. It's transformed with this matrix. So first find the area of triangle ABC. There's that shoelace formula, if you guys remember that. Oh. Okay. They're doing it in an interesting way. I was doing it a meoff theta shortcut, which I don't know would be acceptable. Oh yeah. No, they just wrote it out numerically. I was thinking the 1, 1, 1, 2, 2, 3, 1, 1, and then you multiply these. So then you get 2, the diagonals, 1 times 2, 1 times 3, 2 times 1. Then this diagonal, 1, 4, and 3. You add this up, and it's the left minus the right. So 4, that's what, 7 minus 8. So the area, left diagonals minus the right diagonals. Did I mess that up? I guess I flipped that up because, yeah, it's supposed to be positive. So 8 minus 7, the area is 1. Okay. Oh, yeah, we got it. That's what it is. We don't flip it that way. We divide it by 2. Okay. So that's the area. That was basically the shoelace method, where this is A, B, C, D, E, and F, and they had the formula there. Okay. If it doesn't make sense, just talk to me in class. I'm following along with the textbook. Just ask me, okay? Let's see. So find the determinant of the transformation matrix. Okay, so that's the determinant of that one. All right, so that's just -1 times 1 minus 1 times 1. So that's just -2. Simple enough. Find the vertices of the image. So we're literally going to take our transformation matrix and multiply it by our points. And we get 0, 2, 1, 3, 1, 5. Okay, so our new points, writing them out as coordinates. That looked bad. And threes, man. They're just not my thing. And 1 comma 5. Okay. Finding the area now for the last one. Okay. So finding the so we take the determinant, right? It's the absolute value of the determinant, and then times the area of the object, which is 0.5. So my new transformation is 1 unit. And that's all you need to know for this section. So I know it was a lot. I'm sorry. I tried to wrap it up as fast as possible. But if you are stuck or confused, just holler at me and I'll be happy to walk you through anything.